Hello, my name is Nathan Ashley, and welcome to my Jumpman Juke project for CGT 245. This is my first project out of the three, and in my opinion, is one of the cooler ones that I made this semester. There's a lot of different things that I added in this. There are 5 blueprint actors in this, one being Donkey Kong. Over here, we have the blueprint for the barrel and the spawner. We have the hammer. We have the oil barrel, which deletes the barrels. And then we also have the blueprint player, the paper blueprint player. On top of that, I created the stage completely by myself. I used original assets from the Donkey Kong arcade game. I was able to find a sprite sheet online and a couple tile maps that I used to be able to create this. You can see here there's a texture and then a tile map. Okay, it's a tile set. So if you see here, what I ended up doing was using this tile set and adding collision boxes to specific sections that I needed to be able to create a platform that the player can walk on. As you can see, only like the top little bit is actually a collision, and that is because I needed to be able to make the character jump and not hit objects. So basically, just to be able to make the game work. So if I go ahead and hit play here, there's going to be a sound, and Donkey Kong throws a barrel. So once these barrels end up getting all the way down here, is when I can show you what happens. The player will interact with the barrel, and the barrel will disappear, counting as a hit. Once the barrel hits the player 3 times, the player will be given a game over screen, and a sound will play. Let me just go ahead and get rid of the hammer. I'm going to get rid of the hammer really fast just to be able to show this to you without having to run over it. But like what I was saying before, if the player ends up interacting with the barrel, it'll disappear. And after 3 times, you should get a game over screen and a sound. Yeah. So there's that. Now, if we go ahead and bring our hammer back into the scene, you'll be able to see that once the player runs over the hammer, a animation starts playing. Unfortunately, the animation is a little buggy, and I don't have enough time to be able to fix it. But what ends up happening is the player can now run over all of the barrels that they want, and it will not cause a game over. Now, once you get to the very top, this is where the magic happens, and this is where the end of the game loop occurs. If you go ahead and hit Donkey Kong, then you will be given a "you win" screen. Let me just get up there really fast. And then it plays a little tune, a little jig. Now I'm going to show you some of the blueprint logic that I ended up implementing for all of these actors. So it looks like I kind of lied a little bit. 1, 2, 3, 4, 5, 6, 7. 7 actors, and then we have the game mode and the widgets. We look at the spawner here. This is the event graph for the spawner. It starts with a begin play node, then sets a timer, and then that timer goes to an event, which therefore spawns the actor that we want, and in this scenario is BP Barrel. From there, you get an actor transform node, plug that into the spawn transform, and from there you spawn the default controller, which in turn controls the enemy, being our barrel here. Now, if we open up the BP Barrel blueprint, this is where it gets a little more complicated. We have an event tech node here attached to a movement input with a forward vector. What this does is it makes our barrels move forward, and is pretty self-explanatory. The value is 1, which means that it goes at full speed. Now down here we have a wall detector node, which is coming off of our wall blueprint, which is these things. What I ended up doing was taking a onComponent begin overlap node from the wall detector, and I set a do once node in there. So I connected that, and from there I added this turn char function. Now this function just turns the barrel character, and what ends up happening is it sets an actor rotation on the specific actor, which in this case is our barrel, and it rotates the barrel once it hits the wall. As you can see, do once, turn char, reset. So this makes our loop to where it can infinitely turn on impact without giving us any errors, because it then closes the loop. There's another onComponent begin overlap event here, and this is to the capsule component on our barrel itself. So this is the logic that is responsible for our damage and the overall input with the paper player character. So as you can see, we start by casting to the paper player, which in turn makes us be able to edit it and give it certain qualities that we would like. So from here, this is the damage logic. So it starts with the HP, a HP variable that then gets subtracted by 1 every time there's an overlap with this capsule component. Now, once it will destroy the actor, and then on this branch, this is so this branch then connects to the other logic, which destroys our paper character. So this destroys the barrel, and this destroys the character. So on this branch node, we have it set to, we have our HP set to equal to less than or equal to 0. And when that is true, it's going to destroy our actor, create the widget, display it on screen, and play our end sound for dead. Basically, damage side. And then this is the logic to get rid of our player and have our death. Now, if we go ahead and open up the Donkey Kong blueprint, we can see this all starts on the beginning of play. So at the very beginning, it sets a flip book, which is called DK Thump. And that is where he bangs his chest like this. And yeah, what you do is you set it and then you play the flip book, and then you set a timer by event. So this event is a custom event that is titled play DK roll for 3 seconds. So it's going to then I'm going to now set this flip book to DK roll, and it's going to play for 3 seconds, and it's going to spawn the barrel. Pretty simple, pretty straightforward, but it did take quite a while to figure out. Now, if we open up the hammer logic, what you can see is there's nothing in here except a has hammer variable, which is very important. So if we go ahead and open up our oil blueprint here, this is the logic to destroy the barrels whenever it interacts with the oil barrel. On play, it sets a flip book, which was supposed to be animated but isn't. It's just the exact same frame, but it does play an animation technically. Down here, you can also see there's a on begin overlap node. I used the do once method that I came up with to then cast to the barrel and destroy the actor, and then it also detaches from the controller, therefore getting rid of anything that was controlling or a part of the barrel. Just completely gets rid of it. Over here, this is our paper player, the biggest blueprint in this level, game, whatever. We start off with an event any damage node, which is a part of our health system. Without this, it wouldn't be able to decrement and get rid of our health. So as you can see, it's attached to a minus node, and that is attached to our HP value, which is an integer, which is set to 3. So on begin play, we can also see that we're casting to the player controller, and that is connected to the enhanced input local player subsystem. But to be able to do any of this, you have to get your controller and put that into your object. And you're going to connect all of this to a mapping context node. And then this is connected to our IMC. This is our input thing. And this is where we assign actions and buttons. So our jump is assigned to the spacebar. Our move is assigned to D and A. And yeah. So that's how we're able to control our paper character, is by using this IMC, which is directly correlated to the enhanced input node and the add mapping context. Down here, this is an update animation node, which is a custom function. And this is the logic that plays our animations for the character. As you can see here, this has the has hammer variable as stated before. And when the player ends up, when the player has the hammer or interacts with the hammer, it then plays the hammer flip book, which is when he swings the hammer. So it stops all animations first, sets the flip book, plays the flip book, and then sets HP to 3. That is so you don't get knocked out while using the hammer. I tried to put this on a timer, but couldn't get it to work for some reason. So that's why you just have the hammer infinitely. Again, I just don't have enough time to finish that. On the false connection to this branch node, it goes into another branch, which has a condition here, which is moving on ground connected to the character movement little component here. So if the target is moving on the ground, and that is true, it's going to take us to this branch over here, which has a condition that says get velocity and then vector length. If it is less than 0, you set it to run right. And if it's not, then you set it to the idle animation. So this is our running animation. I just titled it run right, but it uses the exact same one, and we just flip the character to go left and right. And this is the idle animation, just sits there, does nothing. And down here, you can see there's another branch connected to this branch, and that has a get velocity vector. So if our z velocity is greater than 0, set, I don't know what this is, but basically you can see the get velocity is attached to this, and the condition is if it's true, then we're going to be jumping. If not, then we're basically this is jump, this is run, and this is hammer. That's the easiest way you can think about it. Now down here, we have the enhanced input action for jump. Started, you jump. Completed, stop jumping. Enhanced input action for move, add movement. World direction 0.5. So this is our speed. And then you set the control rotation and you connect that to get controller. Now, this is so that we can, I believe this is so that we can turn the character. So on the end of this set control rotation, we have a new rotation, which is then connected to the action value on the enhanced input action. And what this does is it connects to this greater than sign, which then goes to a true false little branch here. So on true, we're going to do nothing. And on false, we're going to turn on the z-axis by 180. Now down here is our logic so that we can interact with every single item that is necessary. So here it starts off casting the BP hammer, which then destroys the hammer, sets has hammer to true, has a branch, which is connected to an actor has tag node. So this tag is basically saying that if the actor has the tag of barrel, it is then going to cast to barrel and destroy it. So destroy hammer, set hammer to true. If item has the tag barrel, cast to barrel, destroy barrel. And it's all of these are pretty similar to just this basic flow here. What ends up happening is if it runs into something and it's not hammer, it casts to BP Donkey Kong. And if it's not Donkey Kong, then it casts to the spawner. So all of these things will be destroyed by our paper character if they end up interacting with them. that is everything for the BP character. And then finally, if we go down over here, you can see our wall blueprint. Now there's nothing in here, but I had to go into here, change the collision settings to be able to interact with the barrel. So those are all of our items here, and that should be everything that I need to show you for this assignment. Thank you for watching. Again, this has been my final project for my Jumpman Juke assignment in CGT 245.